Hello. All right, let's do another problem. So we're going to do problem 3 together. All right, so we have to prove P, X, R, Y, P, X, R, Y. We have to prove this is a parallelogram. All right, so it's kind of obvious in this picture what two triangles we're going to need to get to be congruent. So let's just make our own congruence. So how about we say triangle SXR is congruent to, and then S, I believe, is going to match up with Q. X will match up with R. And then R is going to match up with P. All right, so list all of your congruencies. So just take a moment, list out all 6. I can do it faster if I'm not talking. All right, number your angles, put them in your picture. All right, here's 1, there's 2, 3, 4, 5, 6. You got to squish them. The picture's kind of small. All right, so start with your first given. This is weird. We are given PQRS is a parallelogram. PQRS, the big one, is a parallelogram. All right, so I can use any property of a parallelogram I want. So I'm noticing I can get opposite angles congruent. So if parallelogram, then, oops, the arrow is then. I don't need to write then. All right, if parallelogram, then opposite angles are congruent. And then my conclusion, I can say angle 5 is congruent to angle 6. Beautiful. One part done. All right. I'm also going to use the fact that if I have a parallelogram, I can get opposite sides congruent. Okay. Now you got to keep track. PQRS. Okay? So, from that, there's 2 pairs of opposite sides that are congruent. Side SP is congruent to RQ, but those aren't in our triangles. And then RS is congruent to PQ. Those are. So I can make a conclusion that line segment RS is congruent to line segment PQ. All right, so RS, PQ. All right, perfect. Okay. There is also another given that we have. I'm checking out my answer key for a quick minute here. Okay. I'm sorry. So our next given says that line segment XP is congruent to line segment YR. All right, XP, YR. That is, that actually is too short. However, I can't use angle, or I can't use segment addition because I don't know that segment SX is congruent to segment YQ. However, I can use the fact that opposite sides are congruent in the big parallelogram. So from back up here, I'm going to put another congruency. I'm also going to put that side SP is congruent to side QR. This side's congruent to that side. Now, with knowing that, this is too long. So this one right here is too long. So I'm going to end up doing segment subtraction. And I'll show you how we're going to do this. All right, so if I start with line segment SP is equal, the length from S to P is equal from the length from Q to R. That was our conclusion from opposite sides being parallel. I'm sorry, opposite sides being congruent. And we just learned that XP is equal to YR. This one was given. This one was our conclusion from step 2. I can subtract these. So if I take the length from S to P and subtract the length from X to P, I am left with just line segment SX. And if I take the length from Q to R and subtract away the length from Y to R, then I can conclude that that is congruent to line segment QY. That is my conclusion by segment subtraction. All right, so that is now the side over here in our two triangles. All right, so right now I can get my two triangles congruent by, and that is side angle side congruency. Now, this also tells us that we can use corresponding parts are congruent. So we get to now conclude. Now remember, we need to get this little one to be congruent. Remember, that is our goal. And they told us XP, this side was congruent to that side. And if you notice right there, that is one pair of opposite sides in our parallelogram that we want to show this as a parallelogram. So actually this given was part of what we needed. Now there is no diagonal inside here, so I don't want to use alternate interior angles, but I do want to try to get the other sides congruent. And it turns out those are the corresponding parts that we need in order to prove that this thing's a parallelogram. So I'm going to say if the triangles are congruent, then corresponding parts are congruent. And my conclusion is going to be that line segment XR is congruent to line segment YP. That is the other part we need for our parallelogram. This side is now congruent to that side. I'm up to 4 tick marks, 4 tick marks. So I now have a parallelogram. So I can say if I have both pairs of opposite sides, if they're congruent, then you have a parallelogram. So for a conclusion now, I can say PXRY is a parallelogram. Okay, so I would like you to now do number 4. Nope, I lied. Do problem 5, then you can do 4, then you can do 6, and problems 7 and 8 are a challenge. To do problems 7 and 8, you need to go back to your purple sheet. To prove a quadrilateral is a rectangle, prove one of the following. Well, rectangles are first and foremost parallelograms, so you must first establish that the quadrilateral is a parallelogram. So you got to do a proof like what we just did. Then you need to be on the lookout for one extra property that a rectangle has. So if you have a parallelogram with congruent diagonals, it makes it be a rectangle. Or if you have a parallelogram with right angles, it forces it to be a rectangle. If you want to prove something is a rhombus, then you first have to prove it's a parallelogram. then you need to prove one of the extra properties that makes it be a rhombus. So be on the lookout to try to get consecutive sides or all sides congruent. Or if you can prove your diagonals are perpendicular, that's your extra property, and then it'll end up being a rhombus. So 8 and 9 are challenges. All right, so good luck with this. Practice, 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 and have fun. Bye.